Yes, there are code-compliant issues to consider when preparing the hole for the conduit to pass through the wall. National Fire Protection Association 70, also known as the National Electrical Code, Section 501.5 requires that openings around electrical conductors be sealed to prevent the passage of flames and gases. National Fire Protection Association 70, Article 120.1 states that electrical installations must comply with all applicable codes, including the National Electrical Code. To comply with code, the hole around the conduit must be sealed to prevent the passage of flames and gases. One acceptable method is to use a Underwriters Laboratories listed fire-resistant caulk or sealant. This sealant must be applied in accordance with the manufacturer's instructions. Yes, it is recommended to use the Underwriters Laboratories listed product available for sealing the hole around the conduit. Underwriters Laboratories listed products have been tested and approved by Underwriters Laboratories to meet safety standards. It is always a good idea to contact the local authority having jurisdiction to confirm the specific requirements for the installation. The authority having jurisdiction may have additional regulations or guidance regarding the treatment of holes for conduit passing through walls. Additional considerations include that the size of the hole should be kept to a minimum to reduce the potential for flames and gases to pass through. The seal should be inspected regularly to ensure its integrity. If the conduit is installed in a damp or wet location, additional measures may be necessary to prevent moisture from entering the hazardous area. When dealing with conduit penetrations between a Class 1 Division 2 hazardous location and an unclassified area, several National Electrical Code requirements must be considered to ensure safety and compliance. The primary concern revolves around properly sealing the opening around the conduit where it passes through the wall. Firstly, National Electrical Code Section 501.15 mandates that any openings around electrical conductors must be sealed to prevent the passage of flames or gases. This requirement is crucial in maintaining the integrity of the hazardous area and preventing potential explosions or fires from propagating into non-hazardous locations. Secondly, the size of the hole created for the conduit penetration is a critical factor. The National Electrical Code emphasizes minimizing the gap between the conduit and the wall to reduce the potential for hazardous substances to migrate. While it is practical to drill a slightly larger hole to facilitate conduit installation, the resulting insular space must be effectively sealed. Thirdly, the selection of sealing materials is paramount. It is highly recommended to use Underwriters Laboratories listed fire-resistant caulk or sealant specifically designed for this purpose. These products have been rigorously tested to withstand specific environmental conditions and ensure that they provide an adequate barrier against flames and gases. The sealant must be applied strictly according to the manufacturer's instructions to achieve optimal performance. Fourthly, the wall's construction plays a significant role in determining the appropriate sealing method. In installations involving drywall, fiber-reinforced polymer board, or similar materials, the sealant must be compatible with these surfaces to ensure proper adhesion and long-term effectiveness. Surface preparation, such as cleaning and priming, may be necessary to enhance the sealant's bonding capabilities. Fifthly, it is advisable to consult with the local authority having jurisdiction to confirm any specific requirements or interpretations of the National Electrical Code applicable to the installation. The authority having jurisdiction may have additional regulations or guidelines regarding the types of sealants approved for use, the inspection procedures, and the documentation required to demonstrate compliance. Sixthly, ongoing maintenance and inspection are essential to verify the seal's integrity over time. Environmental factors, vibration, and physical damage can degrade the sealant, compromising its effectiveness. Regular inspections should be conducted to identify any cracks, gaps, or deterioration, and prompt repairs should be made using Underwriters Laboratories listed materials. Seventhly, in damp or wet locations, additional precautions must be taken to prevent moisture ingress into the hazardous area. This may involve using moisture-resistant sealants or installing a physical barrier to deflect water away from the penetration. The National Electrical Code provides specific guidelines for wiring and equipment in wet locations, which should be carefully followed. Eighthly, documentation of the installation is crucial for demonstrating compliance with the National Electrical Code and facilitating future inspections or maintenance activities. Detailed records should be kept, including the type of sealant used, the manufacturer's specifications, the date of installation, and any inspection findings or repairs made. Ninthly, training and qualification of personnel involved in the installation and inspection of conduit seals are important. Installers should be familiar with the National Electrical Code requirements, the proper techniques for applying sealants, and the potential hazards associated with working in hazardous locations. Tenthly, when specifying conduit seals, it is important to consider the specific characteristics of the hazardous substances present in the area. Different types of gases and vapors may require sealants with different chemical resistance properties. The sealant manufacturer's datasheet should be carefully reviewed to ensure compatibility with the anticipated exposure conditions. The National Electrical Code mandates specific requirements for sealing conduit penetrations between hazardous and unclassified areas. Firstly, National Electrical Code Section 501.15 requires that all openings around electrical conductors must be sealed to prevent the passage of flames or gases. This provision is essential to maintain the integrity of the hazardous location and prevent potential explosions from propagating to non-hazardous areas. Secondly, the size of the opening around the conduit should be minimized to reduce the potential for the migration of hazardous substances. While it may be necessary to drill a slightly larger hole to accommodate the conduit, the resulting annular space must be effectively sealed. Thirdly, the choice of sealant is critical. It is recommended to use Underwriters Laboratories listed fire-resistant caulk or sealant specifically designed for sealing conduit penetrations in hazardous locations. These products have been tested to meet stringent safety standards and are designed to withstand the harsh environmental conditions typically found in these areas. Fourthly, the sealant must be applied in accordance with the manufacturer's instructions. Proper surface preparation, such as cleaning and degreasing, is essential to ensure a good bond between the sealant and the surrounding materials. The sealant should be applied evenly and completely fill the annular space around the conduit. Fifthly, the wall construction materials should be considered when selecting a sealant. Different sealants may be required for use with drywall, concrete, or other types of wall materials. The sealant manufacturer's datasheet should be consulted to ensure compatibility with the specific wall materials used in the installation. Sixthly, the local authority having jurisdiction should be consulted to confirm any specific requirements or interpretations of the National Electrical Code that may apply to the installation. The authority having jurisdiction may have additional regulations or guidelines regarding the types of sealants approved for use, the inspection procedures, and the documentation required to demonstrate compliance. Seventhly, regular inspections should be conducted to verify the integrity of the seals. Seals can deteriorate over time due to environmental factors, vibration, or physical damage. Any cracks, gaps, or other signs of damage should be promptly repaired using Underwriters Laboratories listed materials and methods. Eighthly, documentation of the installation and maintenance activities is essential. Detailed records should be kept, including the type of sealant used, the date of installation, the results of inspections, and any repairs made. This documentation will be helpful in demonstrating compliance with the National Electrical Code and facilitating future inspections. Ninthly, if the conduit is installed in a wet or damp location, additional measures may be necessary to prevent moisture from entering the hazardous area. This may involve the use of moisture-resistant sealants or the installation of a physical barrier to protect the seal from water exposure. Tenthly, it is important to ensure that all personnel involved in the installation and maintenance of conduit seals are properly trained and qualified. They should be familiar with the National Electrical Code requirements, the proper techniques for applying sealants, and the potential hazards associated with working in hazardous locations. The National Electrical Code addresses the requirements for sealing conduit where it passes from a Class 1 Division 2 hazardous location into an unclassified area. Firstly, Section 501.15a of the National Electrical Code generally requires that a seal shall be provided in each conduit run leaving a Class 1 Division 2 location. This seal is intended to minimize the passage of gases, vapors, or dust from the hazardous location into the non-hazardous location. Secondly, the seal can be placed on either side of the boundary between the hazardous and non-hazardous area, as long as it meets the requirements of the code. The specific location of the seal may depend on factors such as the type of conduit, the type of hazardous material present, and the specific equipment being served. Thirdly, with respect to the hole in the wall through which the conduit passes, the National Electrical Code requires that the opening around the conduit be sealed to prevent the passage of flames and gases. This requirement is typically met by using a suitable sealing compound or device that is listed for the purpose. Fourthly, when selecting a sealing compound or device, it is important to choose one that is compatible with the materials of the conduit, the wall, and the hazardous substance present. The manufacturer's instructions should be followed carefully to ensure that the seal is properly installed and that it provides an effective barrier against the passage of flames and gases. Fifthly, it is generally recommended to use an Underwriters Laboratories listed product for sealing the opening around the conduit. Underwriters Laboratories listed products have been tested and evaluated to ensure that they meet applicable safety standards and that they are suitable for use in hazardous locations. Sixthly, the local authority having jurisdiction may have additional requirements or recommendations regarding the sealing of conduit in hazardous locations. It is always a good idea to consult with the authority having jurisdiction to ensure that the installation meets all applicable codes and regulations. Seventhly, in addition to sealing the opening around the conduit, it is also important to ensure that the conduit itself is properly installed and supported. The National Electrical Code contains detailed requirements for the installation of conduit, including requirements for the type of conduit, the spacing of supports, and the grounding of the conduit system. Eighthly, regular inspections should be conducted to verify that the seals and conduit system are in good condition and that they are providing an effective barrier against the passage of flames and gases. Any damage or deterioration should be repaired promptly to maintain the safety of the installation. Ninthly, documentation of the installation, inspection, and maintenance of the conduit system and seals is essential. This documentation should include information on the type of conduit, the type of sealing compound or device used, the date of installation, and the results of inspections and maintenance activities. Tenthly, personnel involved in the installation, inspection, and maintenance of conduit systems and seals in hazardous locations should be properly trained and qualified. They should be familiar with the National Electrical Code requirements, the proper installation techniques, and the potential hazards associated with working in hazardous locations. When a conduit passes from a Class 1 Division 2 hazardous area into an unclassified area, there are several code-compliant issues to consider regarding the treatment of the hole prepared for the conduit. Firstly, National Electrical Code Section 501.15an requires a seal to be provided in each conduit run leaving a Class 1 Division 2 location. The purpose of this seal is to minimize the passage of gases, vapors, or dust from the hazardous area to the non-hazardous area. Secondly, the National Electrical Code does not explicitly specify the exact method for sealing the hole around the conduit. However, the general requirement is that the opening must be effectively sealed to prevent the passage of hazardous materials. This implies that any gaps or spaces between the conduit and the wall must be filled with a suitable sealing material. Thirdly, it is recommended to use Underwriters Laboratories listed product for sealing the hole. Underwriters Laboratories listed sealing compounds and devices have been tested and evaluated to ensure that they are suitable for use in hazardous locations. These products are typically fire resistant and designed to prevent the passage of gases and vapors. Fourthly, the choice of sealing material should be appropriate for the specific hazardous materials present in the area. Some sealing compounds may be incompatible with certain chemicals, so it is important to select a product that is resistant to the chemicals that may be present. Fifthly, the sealing material should be applied in accordance with the manufacturer's instructions. This typically involves cleaning the surfaces to be sealed, applying the sealing compound evenly, and allowing it to cure properly. Sixthly, the authority having jurisdiction may have additional requirements or recommendations regarding the sealing of conduit penetrations in hazardous locations. It is always a good idea to consult with the authority having jurisdiction to ensure that the installation meets all applicable codes and regulations. Seventhly, if the wall is constructed of drywall, fiber reinforced polymer board, or similar materials, it may be necessary to provide additional support for the conduit to prevent it from moving or vibrating. This can be accomplished by using conduit clamps or straps to secure the conduit to the wall. Eighthly, the size of the hole should be kept to a minimum to reduce the amount of sealing material required. A larger hole will require more sealing compound and may be more difficult to seal effectively. Ninthly, regular inspections should be conducted to ensure that the seal remains intact and effective. Any cracks, gaps, or other signs of damage should be repaired promptly. Tenthly, proper documentation should be maintained to demonstrate compliance with the National Electrical Code and other applicable regulations. This documentation should include information on the type of sealing material used, the date of installation, and the results of inspections.